Right, so like I said, you have the exercise as shown here. So you're asked for a half section, and the half section must show a cross-sectional view of the I-beam. And as we have seen on here, or when you scroll down, we'll see the I-beam, and you must show the grease nipple in the assembly and show all necessary dimensions, and add a part list, a complete part list that has all the materials and material names. Remember that the part list, all letters must be in caps when you edit. Right, so are there any questions at this stage? So let me scroll down again. So you are asked for a half section of this drawing here, showing a full profile of the I-beam. Right, any questions? Yes, the assembly is on your textbook, and it's exercise number 7. Also on your lecture slides, you'll see this assembly. All right, so I'm going to start off by showing you how you add components, and then I'll then switch to Mr. Miesa's lecture video right at the end, where he discusses the dimensions, and so yeah, where he discusses the dimensions, and then you'll see how this will be visible, or the parts will be visible on the on half of your half section, or where you don't have a section. Right, so every time when I do my assembly drawings, I always start off with the supporting structure, or the main body of the structure. So I'll start off with this body, which is the support for all the components of. You can assume it's really the support for all the components in the assembly. Right. So I'm going to start off with this component over here, and then add components to it. So what you just need to do is redraw it, or almost as if as it's given. So the only difference will be that you'll have to cut off this part. So this is given as a partial section. You'll have to make it a half section. So you'll cut up to this bottom piece here. So so as you see it, so we had hidden detail lines that show the inner profile of the component. So this means that we will cut through material as you see here, and then we have a hole over here. It's this hole that's shown in hidden detail lines. Also remember that we don't dimension hidden detail lines, that they're dimensioned here, but remember for this module we don't dimension hidden detail lines. And then we have here the hole. So I'm just going to show the hole over here, and then add my section line. So this means that in this area we are cutting through some material. Right, so now I go back to my assembly components, and what I see is that I have a bolt. So you can assemble your components in any order. I've identified, this order, so you're not forced to use the order that I'm using for assembling my my components. All right, so I have the shoulder bolt over here, and I see a diameter of 30. And when I go to my support over here, I do see that I have a 30 diameter, which is shown on this view. So this tells me that my shoulder bolt goes into the assembly. What I do not know is from which side the shoulder bolt goes. So I refer to this picture and I see that, so it's not possible that the shoulder bolt goes over here because I have the wheel on this side. So this tells me that the shoulder bolt goes to the ends on the other side, so on this side of my component. And this tells you that, again, we need to insert two of this. Oh, well, we have four of this shoulder bolts. So this means that one will go here, one will go here, and then the other two will go on the other side. All right. So I'm going to, again, like I said, insert the shoulder bolt over here. All right. So let me just go to the other slide. So I've inserted my shoulder bolts. Just ignore the lines that appear here. So I haven't cleaned up the image, but this is the position of my shoulder bolt. Shoulder bolt as well. Yeah, this is what where it should be. But then I realized that actually I have a spring washer, and like I said right at the beginning, is that the spring washer should go with the shoulder bolt. So what I then do is I move my shoulder bolt a bit back so that I can insert, then draw the spring washer. Right. So I've now inserted the spring washer into my assembly, as you see it here. Right. Are there any questions before I continue? Right. So I'm going to go back to my components, and the next component that I then take a look at is the pin. So I see the pin has an outside diameter of 30, and this gives me an indication that, oh, so the pin fits somewhere here. And I look at the internal thread, and I see that the thread is actually an M20. Where is it shown? Supposed to be somewhere here. So okay, yeah, it was supposed to be written here. So, but the internal thread is supposed to be an M20. Yeah. Oh, okay. So there's just a slight error on this drawing. So what happens is that you have an M20 dimension over here, which is not visible. So this is an M20 thread, and I see an M20 thread over here on the bolt. This tells me that the bolt actually attaches to my pin. right? So this will be now my bolt attached to the pin. So again, just ignore the additional lines that should have been removed over here. So just this lines over here shouldn't be there. Right. So I have again my bolt, and I have my pin, and I've then inserted my bolt. Okay, let me see if there are any questions. So the spring washer must always have a larger diameter than. Yes, yes. So the spring washer, its outer diameter must always be bigger than the hole. So if I go back here, you'll see that the spring washer has a diameter of 41. So the outer diameter is 41, and then the inner diameter is slightly bigger than this diameter. This is so that your spring doesn't attach to this bolt over here. So it's always, it can be the size of 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 of, of the bolt, or just slightly bigger. So in this case, we have it as a slightly bigger diameter, but there must be a small gap between the two to allow it so that one can easily remove it from the bolt. That was for Yaku. Does that answer your question, Yaku? Right. Yes. Any other questions? Right. So I'm now going to continue. So the next component that I see, so we've already discussed how the key fits into this part and the slot. And since we've put the pen right or on the other side of this hole, we can add a pin in between the two. Right, so that's quite simple to add. So far we've added the pen, we've added the key to prevent relative movement of the pen, and we see that the bolt holds the pin inside the hole. And again, we saw we see a pathway for lubrication. So which means that we have to add a grease nipple over here. Right, so there's our grease nipple. So shown right on top. Remember, so for your grease nipple and the bolt, you have to show 3 faces of it in one of the views. So since the requirement for this question was 2 views, but we will only draw one. So remember, in one of the 2 views, you must have both the grease nipple and the nut having 3 faces of the head of the nut, as we see here. Yes, so the grease nipple is a standard component, so we don't section the grease nipple. The bolt is also a standard component. We don't add, we don't section it, and even the washer is a standard component, so we don't add any. We don't section it. The next component to then add by just looking at, so we have attached the washer, the key, the this part over here, which is the grease nipple, the shoulder bolt, and the pin. So we are only left with the wheel and the push. So let's just see where the bush goes. So it has an inner diameter of 37, and we see a diameter of 37 over here. So this tells us that the bush goes over this pin over here, and we have a wheel that has a diameter of 42, and we have the outer diameter of the bush as 42. So which means that the bush goes over a pin, and then the wheel then goes over the bush, and we see a lubrication pathway for the bush as well. So which means that the bush will roll over the pin, or will rotate over the pin, and the attachment between the bush and the wheel will be a tight fit. So these two will have a tight fit between them, and this fit over here will be a loose fit. So we'll have a loose fit between the bush and our pin. Right. So remember, we add cross hatching. So what I've added there is not correct. So don't color in your bush for the practicals and exam, and say that this was what was shown to us. So remember, you show cross hatching. When I change to Mr. Miesa's lecture slides, you'll see that there's actually cross sectioning and not it's not filled in. And then the next thing that you then add is the wheel. So this is a wheel. Yeah, there are some lines that are appearing that shouldn't be there, but this is how you make an assembly, or how you take all these components and produce an assembly. You'll see that as a part, the wheel is given here as a half section, but since we are cutting the entire half of this area, we show it as a full section. Right, are there any questions before I switch to Mr. Mesa's video recording? Oh, yes. My apologies for that. I made an error. Yeah, that's an error from my part. So thank you, Kavishan. So the wheel is supposed to face the other direction. That's yeah. I made an error in that regard. So my apologies for that. So thanks, Kavishan and Luandiso. And then Lisma, if you look in the textbook, okay, so it's the wheel problem. So my apologies for that. That's just an error. So I'm going to stop sharing my the slides that I have there, and switch over to the content that was presented by Mr. Nessa. So let me just stop and then share. So it's a Chrome tab.
Okay, and then the question said we can draw a portion of the I-beam as well.
Right. So on the video, as you can see, Mr. Mesa, as he had drawn the components in the section view, he also added what you see on the unsectioned half section. So you will see that the wheel is visible. The external view of the wheel is visible. You'll see the grease nipple, the spring washer, and the bolt are also all visible from the unsectioned part of the half section, and the orientation of the wheel is now shown correctly. And like I said, for the bushing, you always show cross hatching for the bushing.
Okay, this I-beam, we don't know what its length is. So standard practice is then, because we're just drawing a section of the I-beam, it's almost like we're making a section view of the I-beam. So then we just hatch it.
Are there any questions at this stage? Okay. So one thing that you should take note of is the hatching. So the hatching is always so different for different components. So the directions must just be different for different components. So what's missing on this assembly is the hatching direction of the wheel must actually be in the other direction, just to indicate that it's a different component. So the wheel is a different component to the body. Right. So the hatching of the wheel and the body must just be different in that case, because those two are different components. Right. I see there are questions. Okay. So Landiso, why did he section the I-beam? Right. So the reason why he added he sectioned the I-beam is that you don't know how long the I-beam would be. So in the cutting plane, what happens is that the I-beam has been cut already. So that's the reason why we add section lines to the I-beam, to indicate that it has been cut somewhere. Right. So it can be a half section. Reason being that the I-beam, where you see this components, or this drawing over here, the full drawing. So the full drawing, where the cutting plane, where we see this assembly, you'll have a cut I-beam. So we don't know, it's like Mr. Mesa has said, we don't know how long the I-beam would be. So wherever we view this component, the I-beam will be cut. So which means that it will have a section of it visible. So that's the reason why we show a full section and not a half section of the I-beam. That's the reason being, we don't know how long it is, and where we will see it on the assembly, it will be cut anyway. Right, so even if we're not drawing a half section, we will still have a section view of the I-beam. We add the item. Yes, I think, Elisma, that's a good assumption. So when you add your part list, just add all materials as steel. And for standard components, you can say standard. But yeah, for the bushing, it will be some kind of plastic or a brass. So just saying steel is still a good assumption. Right, so let me continue playing Mr. Mrs. video.
Okay, so most of my time was spent on this view because this is the one which carries the most marks as well. So basically we have the grease nipple at the top. Grease flows down that passage into that cavity, down the smaller cavity, past the end of the bolt, just touching the end of the bolt, filling up this cavity, then exiting there and filling up that cavity inside there, which is where the bearing is lubricated. So you might have noticed with this one, there wasn't specifically given big gaps or anything for the wheel to spin freely. Now, typically in practice, what would be done there is a tolerance would be given on the bushing and wheel sizes and the shaft size. So the shaft would be given, for example, as 40.0 up to 40.25, and the bushing would be given as 39.5 to 39.75, and the same for the wheel, to make sure that there's a bit of a looseness, that they don't grab onto each other. Although in this one's case, it wasn't specifically advertised. So there we have everything assembled together. And we can put the I-beam in place. And that's basically the assembly drawing. Now, lastly, what we can do is we can go and add all of our dimensions. So dimension-wise, we would need overall height. Let's quickly calculate that one. So from the center to the center there is 104, plus 25 is 129, plus 45 is 134, 174, more or less. Okay, then also add the 5 millimeters of the wheel, so that's 179. So this distance is basically the width of the body plus 3 plus the width of the bolt's head. width of the body is 40 plus 120 plus 40. That's 200 plus 3 plus 3, 206 plus 24. That's 230. Please remember to always write on top of the line. We still get many students who write beneath the line. And there's actually a big problem with that. Let's say we have some other random shape over there. Okay, is that height 99 or is it 66? Well, technically that dimension should not be trusted in any way. So we always write on top of the line. And this gets especially dangerous if we have multiple dimensions close to each other. Because now it can be 66, 99 or whatever, and then it just doesn't make sense. So that's why always write on top of the line, not beneath the line. Okay, the last overall dimension is the depth into the page, which we will give on the side view. Then we have functional dimensions. A functional dimension would be the size of that hole, diameter 20. There we have diameter 20. Maybe the width of that thing at the bottom there. 20 as well. There.
All right, so for your functional dimensions, so you have overall dimensions, which Mr. Mesa has shown. For your functional dimensions, you have to look at the component. So from this assembly, it looks like, this component moves something from one point to the other, and we see a hole that looks like a hook hole. So your functional dimension would then be for supporting some other material through a hook. So that's the reason why we said those are our functional dimensions. Reason being that this looks like some assembly that transports materials on the rail, and this is the only area where it looks like you have to mount something. So it looks like the function of the component. So that's the reason why those functional dimensions were added.
Then the dimensions of the wheel. So that angle could be important, and the diameter of the wheel could be important on the small side and the big side. think it was 81. Yeah. That's important. Another thing that's important could be the gap between these two pins. That will tell me how wide this I-beam can be. Okay, so the pin is 45 long. That gap is 120, and we've got two 45s. So the gap in the middle is 120 minus 90, so it's 30. That would be a functional dimension as well.
All right, let's just check. Lungelo, for SolidWorks, will I be penalized if I put dimensions in between the lines? Could I change the wheel? Oh, could I change SolidWorks dimension settings on Sketcher? Right, so you shouldn't be penalized on SolidWorks if you've used those field errors, but you can change them as well. So you wouldn't be penalized for it. That's for Lungelo. And then Elisma, if we dimension the smaller end of the wheel, would we be penalized? No. So I think what Elisma is saying is that if you dimension this part and that part over here, so that would then give you the angle. So that would still be fine. Elisma, is that what you are asking? And then Zezetu, is there a purpose of including the I-beam as part of the drawing inside the schematic? So yes, so the I-beam just shows you the mounting, and again, that was the requirement of for a question. So if it was asked of you to add the I-beam, then you should do so. Right. So the last thing to mention for this question is the part list. So remember, always remember to put your items, start from 1 and go in ascending order from the bottom. So 1 to up to 9, and then have your quantity. So even your title block gives you the columns that should be there, and then the description, and then the material. So getting this answer should be this should be 3 marks. This is easy to fill, and then also make sure that your part list, or the items on your part list correspond with the balloons that you've drawn here. So if you're going to draw or label within a component, just take note that the arrowhead then becomes, or the head then becomes a dot. And then if you're labeling outside, or none of the components are labeled outside. If you're labeling outside, remember to put an arrow and not, we've had in the exam some students just put a line and this balloon. So remember to add either on the head an arrowhead, or just a dot.